So the chapter name is Units and Dimensions. I begin with the topic dimensions. Dimensions means there are 7 dimensions. Dimensions I will explain with the help of this paragraph. I will explain the dimension. There are 7 dimensions of the physical world. One is length. Length has the dimension L. Length has the dimension symbol L. Physical quantities, see, there are different types of physical quantities, right? Physical quantities means length is there, understood, temperature is there, mass is there, velocity is there. There are plenty of physical quantities. The fundamental physical quantities, listen, there are certain fundamental physical quantities. They are, the fundamental physical quantities are, one is length. Length is fundamental, right? Clear? Length is fundamental. For example, I want to travel, so the length is very important. Okay, length is very important. It is a fundamental quantity. The length is denoted by the symbol L. Understood? The length has units. Length has different types of units. Centimeter is a unit of length. Meter, yes, it is a unit of length. Kilometer, feet, inch, there are different types of units for length. I am not talking about unit. I am not talking about unit. The length is the fundamental physical quantity. That you agree. That length is denoted by the symbol bracket L. Understood? Length is denoted by L. You will never forget it. The word length is beginning with L, so it is simply denoted by L. The symbol is written inside a square bracket. Generally we write like that. Mass is a fundamental physical quantity, right? For finding the weight or many other things, the mass is required. Mass is required. The mass is denoted by the symbol capital M. The unit of mass have different units. Mass have different units. Kilogram is a unit of mass. Gram, understood. Milligram, I am talking about mass. What I am saying is mass is a fundamental physical quantity denoted by capital M. Time, yes, time is a fundamental quantity, physical quantity. Unit will be second, hour, minute. There are different types of unit for time. Time is a fundamental quantity denoted by capital T. You have to memorize all these fundamental quantities. Then electric current. The current you will learn later, but you have heard about the current. Understood? In the lower classes, you have heard about the current. The flow of electron is there. If there is a flow of electron, we say there is current. You will learn more about current later. In this chapter, we are not dealing with current. Current is denoted by capital A. Don't use C, okay? Don't use C. The current denoted by the symbol A, that's all. Current is denoted by the symbol A. The temperature is there. Thermodynamic temperature or temperature, okay? In simple word, temperature. It is K. We use K because the temperature has one standard unit, Kelvin. You might have heard about the unit, but I will discuss unit later. Don't worry about that. Thermodynamic temperature is denoted by K. It is a fundamental physical quantity. Luminous intensity, this is beyond our syllabus. Luminous intensity is beyond our syllabus. Just learn it, that's all. Luminous intensity means it is a measure of brightness of a light. Luminous intensity means what? It is the measure of brightness of the light. The light can be dim or bright, like that. There is a measurement representing the brightness of the light. Luminous intensity, CD. No need to worry about this one. It is this type of, the question involving luminous intensity will not be there, okay? Don't worry about that. But in question, in exam, if they are asking, write the 7 dimensions. You have to write all these things. Length, mass, time, current, temperature, luminous intensity. And one more thing is there, the amount of substance. Mole. amount of substance denoted by the symbol mole. You might have heard about the mole, understood, Avogadro number. But the question involving amount of substance is not there in this chapter, so no need to worry about luminous intensity and amount of substance. No need to worry about that. So the 7 dimensions means the 7 fundamental physical quantity. That's all. Fundamental. There are 7 fundamental physical quantity. So there are 7 fundamental physical quantities called dimensions. And remember the symbol representing each dimensions. There are 7 such physical quantities. All other physical quantities are derived from the 7 basics. All other quantities like velocity, displacement, velocity, acceleration, pressure, density, there are so many physical quantities, right? All other physical quantities are derived from this fundamental 7 physical quantities called dimensions. Okay, so dimensions is clear, and remember the other physical quantities are derived from the 7 fundamental physical quantities called dimensions. For example, there are plenty of questions based on dimensions. For example, velocity. There are so many examples. Velocity is not a fundamental quantity, but it can be expressed in terms of any of this fundamental physical quantities like length, mass, current, temperature, like that. Velocity, I will tell you. Tell me one of the formula representing velocity. Tell me one of the formula. Velocity is equal to displacement by time. My objective is I want to write the dimensions of this physical quantity velocity. The dimensions of velocity is derived from this any of the 7. Velocity equal to displacement time. Now, displacement has the dimensions. Then you have to write the dimensions of each quantities. Displacement is displacement belong to length. Understood? Displacement belong to the category length. Does displacement belong to the category mass? No. Displacement belong to the which category? I have a 7 category. Look here, I have 7 category. Among this 7 category, displacement belong to which category? Is it mass? No. Is the displacement temperature? No. So displacement belong to the dimension, what is that? Length. Understood? Displacement belong to the category length. So you have to identify the right category. Normally we write the symbol inside a square bracket. That is the way we write. I am writing the dimensions of velocity. Time. What is the category of time? Time, look here, you see, you can understand. Time is t. So directly the time is t. Capital T. Right. So okay, we have to simplify this. Normally we use a square bracket. Okay, normally we write everything inside a square bracket. L is there. Okay, 1 by t, isn't it? 1 by t. You studied in the lower classes that in maths you studied 1 by x is denoted by x raised to minus 1. Have you studied this basic things in maths? 1 by x is denoted by x raised to minus 1. Nadasha പഠിച്ചിട്ടില്ലേ ഇങ്ങനെ ഒരു സംഭവം? നടാഷ, ഹലോ, അറിയില്ലെങ്കിൽ ബൈ ഹാർട്ട് ആയിരിക്കോ? ആരോൺ, ദേവ, അണ്ടർസ്റ്റുഡ്? രക്ഷന? And
Yes, sir. I use it before.
now remember this one also. 1 by x raised to n. This is simple maths. You studied in 7th and 8th standards. 1 by x raised to n is denoted by x raised to minus n. There will be expressions like 1 by x square, 1 by x cube. We will write like this. Okay. Now coming back to this question, 1 by t is there. 1 by t is there. 1 by t is written as t raised to minus 1. This is the dimension. Dimension of a physical quantity means it is a combination. It is the combination of the basic dimensions, length, mass, current, like that. So any physical quantities can be expressed using any of these 7 dimensions. These 7 dimensions are the fundamental physical quantities. So acceleration, pressure, density, everything can be written in terms of length, mass, TA, etc. Okay. I suggest you better memorize the dimension of velocity, Lt raised to minus 1. I will write here memorize. Velocity and acceleration, at least these two you have to memorize. Okay, so Lt raised to minus 1, you please memorize the dimension. And you may be wondering why we are learning dimensions. Definitely there are applications of dimensions. Definitely we will learn it later. Definitely there is a applications of dimensions. Using dimensions we can derive formula. Using dimension we can derive the formula, and also we can check whether a given formula correct or not. Two applications are there. One application is we can check whether the given formula correct or not. The another application is we can derive certain formula by simply knowing the dimensional analysis. We will learn it later. Okay, for the time being let us try to try to understand how to write the dimension. Okay, now let me write another example. Example 2. Question will be like this: write the dimension of acceleration. Okay, the question will be like that: write the dimensions of acceleration. Acceleration, right? To write the dimension you have to use one of the formula for finding acceleration. Select a simple formula, t by time. Okay, the change in velocity, or simply write velocity by time, change in velocity by time. The velocity I have already explained. You have to memorize the dimension of velocity. You must at least memorize velocity and acceleration. The dimensions of velocity we have studied. What is the dimension of velocity? I told you have to memorize this. If you don't memorize this, you have to write these steps. You have to write all these steps. So I suggest you memorize this. Velocity has the dimension Lt raised to minus 1. So the velocity has the dimension Lt. Normally we write everything inside the bracket. Okay, but in simplification, at the simplification time, we will not look at the bracket. Okay, time, dimensions of time is capital T. We need to simplify this. How to do this? Remember this t, if I write t as, I can write t as t raised to 1. Is there any problem if I write t as t raised to 1? No problem. T raised to 1 is t itself. And remember, in the lower classes you studied two identities. One is a raised to m into a raised to n, product, equal to. So in the lower classes you studied that a raised to m into a raised to n is a raised to m plus n. Studied it. Very simple identity. And another one is a raised to m by a raised to n. Division, a raised to m minus n. These are required in dimension related questions. If there is multiplication, we will add the powers. If there is division, we will subtract the powers. So I want to reduce it. So L is there, t raised to t raised to minus 1 by t raised to 1. So we have to subtract the powers. Subtracting the power means minus 1 minus 1. Clear? The power in the numerator minus power in the denominator. I am writing all the steps. So the acceleration has the dimensions L t raised to minus 2. So every physical quantity has a dimensions containing the 7 fundamental dimensions: length, temperature, mass, like that. So I suggest this one also you have to memorize. Acceleration dimension you have to memorize. Velocity has the dimension L t raised to minus 1. Acceleration has the dimension L t raised to minus 2. To write the dimension, you have to write one of the formula, the simplest formula, right? And write the dimensions of each quantities. Simplify it. L may be written as L raised to 1, but it is not necessary, okay? L is same as L raised to 1, but it is not necessary actually, okay? Understood? L raised to 1, L both are same thing, isn't it?
So just one doubt, sir.
Yes. So next is we have to write the dimensions of force. Next question is this: write the dimensions of force. So to write the dimension of the force, you have to write one of the formula for finding force. We prefer the simplest formula. So just multiply them. This is simply a product. I am just writing a bracket. So just multiply all these letters. M into L into t raised to minus 2. Correct? M into L into t raised to minus 2. You need not memorize this, because memorizing the dimension of all physical quantities will be very difficult. But at least memorize velocity and acceleration, because these two are required for finding force, work done, etc. So it is needed. So let me use area, length into breadth. The formula is required, otherwise you cannot write the dimension. Length into breadth. So dimensions of area, let me write like this, because I don't want to use area like this, because current is denoted by A. That is why area has the dimension dimension of length. Dimension of length means length belongs to which category, that's all. Dimension of length means length belongs to which category. Length belongs to, I have 7 fundamental quantities. Among this, length belongs to the quantity capital L. Understood? Length belongs to the category capital L. So the length belongs to the category capital L. Breadth belongs to which category? Breadth is also distance, right? Breadth is also some distance. Maybe centimeter, maybe millimeter, something. I am saying breadth belongs to which category? Breadth has the unit meter or centimeter or millimeter, whatever may be. The breadth belongs to which category? I have a 7 category. Does breadth belong to the mass? No. Does breadth belongs to the category time? No. So the breadth belongs to the category L itself. Clear? The category L. Breadth belongs to the category L. Understood? In general, the distance is denoted by capital L. In general, the distance denoted by capital L. So breadth belongs to the category L. The breadth belongs to category L. Category L, that is correct. Understood? All the distance belongs to the category L. Understand? So L into L. L into L is L square, correct? L into L is L square. So please, I think it's very easy to memorize that. Area has the dimension L square. Example 5. There are plenty of examples. Volume. Yeah, you have heard about volume, right? Volume, I have to write one of the formula for finding volume. Example 6. Density. All this, I'm not saying that you need not memorize all this, but velocity and acceleration you better memorize, okay? Density, the next is dimension of density. And the next, there are examples. Actually, these are, it is there in the textbook question. Write the dimensions of the following physical quantities. The example 7 is pressure. Pressure P. For the time being, you please understand the pressure means, listen, there is an area. There is an area and there is a force acting on this area. Uniformly there is a force. For example, a vehicle. A vehicle is standing on this area. Understood? A vehicle standing on this area. So the weight of the vehicle, the total weight of the vehicle, let it be F, force. Area, let it be A. Total force acting on this area, understood? Total force acting on this area, let it be F. The area is A. Pressure is the force acting on a unit area, understood? Unit area, how much force experienced by a unit area, that is said to be pressure. The force is equally distributed. The force is equally distributed to every point on this area. The pressure is the force experienced by a unit area. Understood? That is pressure. I don't want to spend more time on this because you will learn it. You will learn more about pressure in the another chapter. For the time being, you just understand that pressure is force by area. Force by area means one unit area has to withstand how much force. How much force is, I mean one unit area experience how much force. Understood? So force by area is the formula for pressure. I have to write the dimensions of force and area. Since we have not studied the dimension of force, I need one more, we have to write the formula of force. Because we have not studied, we have calculated it, but we have not studied it. So we have to write the formula of force, mass into acceleration. Force has the dimension, formula mass into acceleration. Area, we have studied it, L square, but let it be length into breadth. Okay, let us write some extra steps. We have not studied the dimensions of force, so I have written the formula of force. After that I will write the dimension. Thing is, force dimension we have not studied it, but we know how to calculate it. The force has the formula mass into acceleration. Now I am writing the dimension of pressure. The mass has the dimension capital M. Mass has the dimension capital M. What is this A? A is the acceleration. I told you to memorize it. I told you to memorize that. Acceleration has the dimension L t raised to minus 2. Length belongs to the category distance. Every distance related things has the dimension L. Distance related items will have the dimension L. Length has the dimension L, breadth has the dimension L. You need not confuse with this bracket. Normally we write everything inside the bracket, okay? So if anything cancel, you can do it, okay? If there is any same number in the numerator and denominator, you may cancel it. You need not worry about the bracket. this L and this L cancels. L cancels. What is left? M is there. 1 by L is there. Okay, I will. Okay, 1 by L is there. Yes, definitely. 1 by L is there. 1 by L is L raised to minus 1. I have already discussed that. 1 by L is L raised to minus 1. T raised to minus 2 is there. T raised to minus 2 is there. And you may write M as M raised to 1. Okay. I want the dimensions of work. You studied in 9th standard, not in yes 9th standard. 10th standard there was no work done. 9th standard it is there. Anybody, do you remember work done? Nadasha,
Sir,
tell me.
force into displacement.
Yes, correct. Okay, Nadasha, Aaron, you studied, and also this year we will learn more about. This year also we will learn more about work. There is a chapter number 4. Chapter number 5 is actually work energy power. In that chapter you will learn more about work. For the time being, you please understand, work done denoted by W. It is force into displacement. F into D. Force into displacement. Let me write it in words. Force into displacement. Displacement. Work done means how much effort I am doing for moving a body. Understood? For example, there is a body here on the surface. In order to move it from one point to another point, a distance D, the force is necessary. Then only the body will move. So by using a force, the body has got a displacement D. So how much work I have done, or how much effort I have taken, or how much energy I have spent. Understood? How much effort means how much energy I have spent. We may say like that. The work done equal to force into displacement. So I am going to write the dimension of work done. The force we have not studied, but we know how to find the. Let me write the formula. Force is mass into acceleration into displacement. Let me denote by D. Now I am going to write the dimension of work done. M stand for mass, capital letter. A stand for acceleration. We have studied that. L into T raised to minus 2. D stands for distance or displacement, belongs to the category length, L. You have to multiply. L is L raised to 1. Here also L is L raised to 1. M raised to 1. Okay. L raised to 1 into L raised to 1 is L square. Correct? L raised to 1 into L raised to 1 is what? L square. T raised to minus 2. And also please remember, work done and energy have same dimensions. We will learn the connection between work and energy later in the chapter work energy power. For the time being, work and energy have same dimensions. So if the question is about the energy, you may simply write the dimension of work done. Why work done and energy are same thing? Because how much work I have done means how much energy I have spent. Understood? How much energy I have spent for moving this. Work and energy have same dimensions. Please note it. Okay.